My name is MÁRTON JÁNOSY from EDIMÁRT, one of the leading language solutions providers in Hungary. And I think my presentation will tie very nicely into some of the things that Csaba talked about, because he's provided us with a very nice and detailed background, and I'm going to talk about the other side of the story, the practical applications, and I'll show you a history of the past few years of how we started to use this technology and how we kind of evolved and improved our tools, and how there was also at the same time a non-evolution of ready-made tools. So with that, let's get started. November 30th in 2022 was the day when our industry and many other industries changed forever. That was the day ChatGPT was launched, and I'd been experimenting with earlier models before, but this moment I think was different, because suddenly things I never imagined a machine could handle, such as rewriting text or applying semantic tags or adapting style or translating with special instructions. All of these became possible, or at least we were able to efficiently support them using automated workflows. And now this was available to anyone with an internet connection, and they could use it for free. So I thought that basically this is it, and within a few months AI would be quickly integrated into every major CAT tool, and it would surely automate almost any linguistic task, from file preparation to QA. I also thought that we'd have loads of machine translation plugins and solutions that would be able to efficiently use translation memories, talk to term bases, style guides, incorporate reference materials to deliver MT quality that we'd never seen before. So I thought it's time to sit back and let's just wait for those tools to arrive. But fast forward to summer 2023, nothing like that happened. So yes, some MT providers had started experimenting with LLM models, but the improvements were small, at least small to me, and many of the old problems were still there. Translation was limited to one segment at a time, which is a very, very serious restriction and a very big problem even today. Tag handling was broken, and most importantly, there was no control for the user. So all these parameters that Csaba mentioned, like the temperature, or writing your own prompt with your own instructions, that's typically not available in ready-made MT solutions based on AI. So I thought, all right, this isn't coming anytime soon, and I was wrong to expect it so quickly, but if I can't have a toolbox of ready-made tools that I need, maybe I could at least try to build my own temporary one. I was thinking of a Swiss Army knife solution that we could use for all kinds of linguistic tasks, and that's how we created EDIMÁRT's first piece of software to exploit GPT and LLM technology. And it could handle almost any linguistic problem that the user was able to define in a prompt. That was the idea behind it. It wasn't fully integrated into our TMS of choice, MemoQ, partly because of processing time, partly because keeping things separate made it more flexible. Let's not go into the details. And I'll give you a couple of examples of how it worked and how it works. So it starts by reading an XLIF file, which is the export format of MemoQ, and inside that file There are data and metadata, things like the source text, the target, languages, QA warnings, comments even. And so these parts of the file can be dynamically referenced in the prompt using placeholders. And then I use this prompt to process each segment of this file using OpenAI's GPT models. I can define which model to use and what parameters I want the processing to have. So I can define the temperature, the maximum tokens, and so on and so forth. And then that generates a response for each segment that I can write into the target field of the XLIF for translation, for instance. I can override the source, for instance, if I want to do sophisticated tagging of the source text. I can save it to a comment for special use cases, or I can export it into a CSV file, which is great for term extraction. And just a couple of examples. This is a very simple translation prompt with placeholders. And at this level, it's nothing groundbreaking. In fact, this is exactly what most AI MT engines are doing right now. The difference is in those systems, the user never even sees the prompt, let alone has the chance to adjust it. So with our approach, the prompt is right there. You can look at it, change it, fine-tune it, and you're in control of how the model works on your text. Here's a more advanced example for translation where I use regular expressions in the prompt to kind of parse out relevant terms from QA warnings, so that's quite tricky. But the benefit is obvious. You get precision, you only get the relevant terms and the relevant information injected into the prompt, and so you're not flooding it with extra information, and that way the model can efficiently handle and do this terminologically accurate MT translation. Another example is term extraction. I talked about this. So with this setup, I can define exactly what counts as a term. And so the extracted terms can then be saved directly into a tabular format. And so that makes the whole process far more efficient and simpler and more accurate than the traditional statistical methods. And the last example I show is tagging source text based on semantics. I talked about this. So this is something that you wouldn't be able to handle with regular expressions, which are traditionally used for tagging stuff. So with the LLMs, you can tag segments by their semantics, based on the meanings. And so that opens the door to types of analyses and processing that were impossible with earlier models. And with this approach, we managed to cover a wide range of tasks from document preparation to machine translation to QA. Now, to be clear, I always expected and I still hope that these functions would eventually be available directly inside the TMS. Fully integrated, that would be the natural place for them. But as far as I know, no CAT tool today comes anywhere close to offering this kind of broad functionality. And so that's a bit sad, honestly, because the technology is clearly capable of doing this. And it's been almost 3 years since ChatGPT was launched, and yet no CAT tool has pulled all of this together into a fully integrated solution. So I find myself still surprised by that, and I'm not entirely sure what to make of it. Then again, history is full of expectations that didn't play out quite the way people imagined. In the 60s, we all thought we'd be flying around in cars. Today, we're still mostly stuck in traffic, except we have better navigation apps. So maybe that's just the way the world is. But by the middle of 2024, I again started to have this feeling that we are very happy using our own Swiss Army knife, but there was still a problem. It was just a Swiss Army knife, and it could do a lot of things, but it wasn't the kind of specialized tool for machine translation specifically that I really needed. So again, a few interesting products did show up, but they had serious limitations. They were usually tied to one TMS, and even MemoQ's own LLM-based engine, AGT, wasn't very convincing. More on that later. So once again, I thought, if the market doesn't have the solution I want, I'll build it myself. This time with a focus on machine translation and building it exactly the way I want it to work. And I had 5 things I was looking for in a professional MT solution, and still to this day I cannot name a single MT solution that has all 5 of these exactly the way I want them. So number 1, I want the solution to look beyond just one segment at a time. I think it needs to understand context, and it should also respect and retain the original segmentation, which is still very important because we still have CAT software. Number 2 and 3, like I said, it needs to efficiently manage and use any available terminology or translation memory hits. It should be able to use references or to have a knowledge base like Csaba mentioned, and the lookup logic for those references should be based on semantics, not on character matching. And lastly, I find it very important that the user should be able to adjust and personalize it, because no 2 projects are ever the same and every workflow is different. So the tools should be able to adapt accordingly. Here's a comparison of 3 tools. The first row has DeepL in it. I think it's representative of most neural machine translation solutions. Then we have AGT, which is a typical AI-based solution tied to this one particular TMS, MemoQ. And I think many of the similar solutions on the market have kind of the same limitations or kind of the same logic behind them. And in the last row, we have our own solution, which I call PromptLock MT. So if you look at these, neither DeepL nor AGT is context aware. They are limited to one segment and they are completely blind to whatever comes before or after that given segment. In PromptLock MT, we can handle an arbitrary number of segments together, and the machine also has a memory of earlier inputs and outputs as it's processing the translations. Now, the way we incorporated TB hits is we can handle both allowed and forbidden terms. These are categories inside MemoQ that we can define on a project or client-specific basis. AGT handles allowed terms. It's fully integrated with MemoQ in both AGT and PromptLock MT. DeepL does have some kind of solution for handling TBs, but it depends on language, and it's even more limited in that case, so it's not very efficient. I wouldn't recommend it. DeepL cannot integrate with translation memories. AGT can, of course, with MemoQ, and so can PromptLock MT. And you cannot use any kind of knowledge base with DeepL. With AGT, you have something called live docs, and if you're a user of MemoQ, you know what that is. And you also know that the lookup mechanism is based on edit distance, just like in the case of TMs, which is a problem because I think it should be based on retrieval augmented generation or semantics-based matching. So even if I have completely different words or phrases in my reference materials, it should be able to find the relevant chunks and inject them into my prompt if there is a semantic similarity. And lastly, the first 2 solutions give very little, if any, control to the user. And like I said, I created PromptLock to be fully customizable. You have full control over the prompt, the model, which also means if tomorrow GPT-6 comes out, I can use it tomorrow. You can't typically do that with these ready-made AI solutions. I can use my own fine-tuned models, and I can configure the parameters as well. So let's see how I managed to achieve these 5 elements of what I think are crucial to an empty solution. Instead of translating one segment at a time, my system uses a sliding window. In this example, you can see that I'm processing 15 segments together, and I keep a memory of 5 of the last messages, and so that ensures consistency, and as new batches are added, the oldest ones are dropped, and so this way the model has recent context without being overloaded. And in practice, that also means that key information, even if it only appears here and there, can be retained, and the translations can be created consistently accordingly. In this window, you can select any number of TMs and TBs. These come from our MemoQ server, so there's full integration there via the MemoQ Resources API. You can set the match rate threshold, that's an arbitrary number, and term bases are applied during translation, and like I said, you can include allowed and forbidden terms as well. So on this tab, you can also select term bases. And when it comes to references, the idea is simple. I want any document that could be useful, like documentation, specifications, relevant legislation. I want the user to be able to load that into this solution regardless of the language. For example, if you're translating a privacy notice or something related to GDPR, you may want to load the law itself into this system as reference. So when the system detects a relevant section, it pulls in the matching part of the regulation and injects that into the prompt. So that way the translation is guided by the exact language of the law instead of relying on memory or guesswork. So this makes references far more powerful than edit distance matching, because it's based on meaning or just surface similarity. And it's an example prompt. It's not a problem if you cannot see what exactly that small print is. You can see the main parts, and this is actually quite a minimal prompt we actually use, so we have much longer prompts with placeholders. So we have a task definition, we have instructions for formatting, so that's non-linguistic formatting. Then we have linguistic instructions. Here I have placeholders for TM and TB matches, and remember, I could have lots of other placeholders there for references and for other stuff. And I also have a number of reasoning steps, because these most recent models actually do everything in separate steps, and so I want the model to verify a couple of things before it actually produces a final output. So here's what my prompt looks like. It's not just a single instruction, it's a template that brings together everything the model needs. So it starts with the task instruction, which sets the overall behavior. Next, we insert terminology and what I call examples, and there are actually two sources of examples. One comes from my translation memory, the other comes from what I call on-the-fly matches, and this means that translations the system has just generated are stored and immediately reused if similar text appears later. So consistency is enforced throughout the whole document. Just think of it as a TM which is being created and used on the fly as this machine translation process is going on. And then we also have the reference materials, and the relevant chunks are also included in the prompt. And then basically at the end, I have this prompt, this special prompt, which is specific to every segment. And like I said, the last important thing is customizability. So I can integrate this solution with any MemoQ server. I just need my server URL and my credentials. I can set the context length, so the sliding window is as short or as long as I need. I have free choice of models, so any embedding model for the references or any GPT model for the processing, including fine-tuned ones. I have control over temperature, and for these new reasoning models, I have parameters like verbosity and reasoning effort, so I can also set those to my taste. And lastly, the prompt is fully customizable with placeholders. So in short, the empty solution always fits the project and the client and not the other way around. And so that's why we actually have an extensive project and or client-specific prompt libraries. And the last piece of development that I want to show is a QA plugin that I built for MemoQ. Now, MemoQ does have QA built in, but let's be honest, it's not always very efficient. There are many false positives, false negatives, and so it usually takes a long time to go through all those warnings and to carry out those checks. And so this is supported and built on top of the existing MemoQ QA as a plugin. So this one is fully integrated into MemoQ. And as you can see, again, you can choose your model, you can choose your parameters, and you can make it very fast, because one of the problems with AI-based QA is that it takes time. I figured out that you can actually, if you're in the right tier as an OpenAI user, you can do this in parallel. So you can do 100 segments at a time in the same amount of time it takes to process a single segment. So that makes it incredibly fast. And as always, you can define your own prompt in a simple TXT file. So here's an example QA prompt. Again, this is very minimal, but what you see here is basically an LQA framework I defined as a prompt. Or if you prefer, it's just a list of issues I want the system to check for. Again, I specify the output format and the categories I'm looking for, and it's not going to include any categories that I don't want to be included. And let me show you what it looks like in practice. That's quite small, but I'll try to zoom in maybe this way. So in each of these sentences, I have a mistake that traditional QA algorithms wouldn't be able to pick up. She wears a red dress every Sunday. Minden vasárnap piros ruhát hordik. The Hungarian has a serious conjugation error there, because that suffix is not really the one that we should use there. In the second example, the train leaves at 6 o'clock sharp. A vonat pontosan 7 órakor indul. Instead of 6, I have 7 in the Hungarian text. Now, you could argue that you could come up with some kind of sophisticated regular expression-based rule to fix this or to find this kind of error, but usually if you have numbers spelled out as words, they don't work very well. So, third example, please close the window, kérlek csukd be az ablakot és kapcsold le a lámpát, which contains addition. So it says in Hungarian, it says, please close the window and turn off the lamp, or turn off the lights. He bought a new phone and a laptop. Vette egy új telefont. This is the opposite. We actually dropped some information in the translation. The weather is very cold today. This is a mistranslation, because instead of cold, I have hot. And the last one, the new policy will be effective starting next Monday, and you can see that there's untranslated stuff there. And you wouldn't be able to find these mistakes with traditional QA, but we all know that they do happen because we are humans. And so here's how they show up in the QA window. Each problem is listed with a clear description, and the system even provides the suggested corrections. So fixing them is as easy as just copying and pasting that into my target segment. And I hope you can see that it correctly identified all of the other problems as well. So instead of these vague general warnings and false positives, I get a focused and practical list of issues that actually matter, and I can easily fix them. So, to wrap up, what I've shown today wasn't built as an experiment or a hobby. It was built out of necessity. We needed specialized tools, waited for the miracle to come. It didn't, so we made them happen. So now we have a comprehensive ecosystem, a three-piece software family that effectively supports the entire workflow of localization of language projects from preparation through MT to QA. And my hope is that it sparks ideas for users, LSPs, developers, because if we want progress, we can't just wait for flying cars. We have to roll up our sleeves and start building. Thank you very much.